Today we're going to learn how to define and identify prime numbers. So last time what you did was you learned something about factorization and the number of factors, and you investigated how many factors does each whole number have. And what you found out was that there were different categories. So for examples, if you have a number like maybe 1 is a one is a unique number because it has only one factor, and the only example that we have is 1, which is 1 times 1, and there are no other ways to factorize 1. Then you had numbers which have exactly two factors. So you had numbers like 17, which up to changing the order, like saying 1 times 17 or 17 times 1, or numbers like maybe 7, which can be written as 1 times 7, such numbers which only have two factors, they're those kinds of numbers. Then there are numbers which have multiple factors, and I'll say greater than two factors, and these are numbers like maybe 24, which you can write as 1 times 24, which is also 2 times 12, which is also 3 times 8, which is also equal to 4 times 6. And you'll have numbers maybe like, so this includes numbers like maybe 6, which can be written as 1 times 6. It can also be written as 2 times 3. So there's another category of numbers like 24 and 6, which are greater than two factors. And there's a unique number which has infinitely many factors. And that's the number 0, because you can think of 0 um, as 0 times 1. You can also write it as 0 times 2, which you can also write it as 0 times 3. You can write it as 0 times 4, and so on and so forth. So it seems to have all these factors which seem to be infinitely many. Now, what turns out to be interesting is that there are two categories which are of interest. So I'm just trying to get the examples to be highlighted here in blue. So here are the examples. Now, it turns out that there are only two interesting categories that we actually care about. The number 1, which has only one factor, and the number 0, which has infinitely many factors, are in general not interesting. Okay, but these two categories, which have either exactly two factors or greater than two factors, finitely many greater than two factors. These two categories are very interesting. Okay, and this is the category of prime numbers. So, with uh, numbers which have exactly two factors are called prime, and numbers which have greater than 2 but finitely many are called composite. So now it's not very obvious why we care about these two categories and why this special way of categorization in which we are counting the number of factors as being important. It turns out that these prime numbers play a very important role in all modern banking financial transactions, and they are critical for making any internet transaction that you do to be secure. Okay, so now let's start to worry about how do we identify prime numbers. Okay, so here's a question: is 35 prime? So you want to figure out, is 35 prime? So here's a question: is 35 prime? Okay. Now, the way you know is, well, obviously 35 is clearly 1 times 35. That's true for any number. But now you want to find other factors of 35. So now what you want to find is actually numbers that divide 35, right? So that's the same, because if a number is a factor of 35, that means it divides 35. So let's see. Does 35 divide 2? Now, Does 35 divide 3? No. So this does not divide 2. This does not divide 3. Does 35 divide 4? No. Does 35 divide 5? And the answer is yes. And the answer is yes, because 35 divided by 5 is actually equal to 7. So we can write 35 as 5 times 7. So which means 35 is a composite number. It's not prime because it has more than factors. Okay, so now here's another question that I can ask. What about a number like 23? So is 23 prime? So here's the question, is 23 prime? And clearly, as we started earlier, 23 is 1 times 23, so we already have two factors. So these are two factors. But are there any other factors? Well, the way we have to do is we have to look at 23 divided by 2, and 23 divided by 3, and 23 divided by 4, and so on and so forth. And we have to, so 23 divided by 2, as you know, is not a whole number. 23 divided by 3 is not a whole number. 23 over 4 is not a whole number, and this will go on all the way, and you'll have to check divisibility all the way up to 23 divided by 22, and it turns out that 23 divided by 22 is also not a whole number, right? So what that means is that 23 is prime, because 23, you see, we want to write 23 as a product of two numbers, so those numbers have to be smaller than 23. They can't be greater than 23. So we go all the way up to 22, and then we find out that 23 is prime. So this is an algorithm. So this is an algorithm. You should know this word. So this is an algorithm for discovering whether a number is prime or not. You divide all the way up to that number, and if it divides by a number between 2 and a number 1 less than that number, then it's going to be not prime. If it does not, then it is prime. As simple as that. So now, as a homework or as a practice exercise, I would suggest that you find out whether these numbers are prime. So here's my question: are 15, 91, 96, and 43 and 29, are these prime? So the question is, are these prime numbers? And you can just use your divisibility algorithm to figure out whether these numbers are prime. Go ahead and try it.